Okay. Good afternoon. Welcome back. This is September 14th. If you're with me here in fall 2020, today we're choosing between different growth models. Right? We're leading up to exam one. We're almost there, but we need just a few more topics before we get there. The first assignment this week is more of a review assignment than anything. It's actually made up of several types of questions which were on previous homework assignments. But they're mixed up in such a way that it doesn't tell you which model that you're using for every problem, right? In the previous homework problems, then you could be pretty well assured that you know exactly which model you're using because that homework assignment was called compound interest, or that homework assignment was called present value annuities. Right? But now, and on the exam, you won't be told that. You'll have to know by looking at different kinds of situations and realizing the difference between the models. Right? You'll have to see exactly which one that you'll need for any given situation. Right? And so that's what this assignment is designed to help you practice. Right? And then after this, we'll have a secondary topic about amortization tables. It's not new technically, but most people haven't made a table by hand before. So I'm looking at all the different models that we have. Right? We fall into three basic groups in this class. Either we're talking about simple interest, we're talking about compound interest, or we're talking about annuities. And this could be future value or present value. They fall into the same category. I know they are two different formulas, but they fall into the same category, right? It's 1, 2, or 3. So let's compare and let's contrast several of these things. When I look at this, simple interest and compound interest are very similar, right? We can technically have a bank account which models this, right? Although you won't find too many bank accounts which do simple interest, right? More often than not, simple interest is going to be something like in a bond payment scenario. We had some homework assignments about bond payments previously. One dead giveaway that you're looking at simple interest is that it actually says simple interest. Right? That word simple will have to appear in the problem. Right? Because if we're talking about an interest rate, it's 4% simple interest or 4% annual simple interest. It'll have to actually say the word simple. And the reason why it has to say the word simple is that if it doesn't say simple interest specifically, then it is compound interest. Right? This is the default. This is the default interest that you should be thinking about. Is compound interest. So unless you have good reason to think otherwise, right, it's a compound interest scenario. Even in annuities, we saw earlier last week that compound interest is what's going on underneath the hood of annuities. It's just growing a little bit at a time, and then we're adding a little bit more. And then it's growing a little bit more, and we add a little bit more. But underneath all of it is compound interest. And so usually these situations have to do with banks, sometimes investments. Those are very common compound interest scenarios. Simple interest scenarios, we saw this with bonds. Right? There are certain kinds of bonds that we would not do this for, but most of the bonds we talk about in this class we think of them as simple interest because of the coupon payments. We think of the coupon payments as interest, and since the coupon payment is exactly the same every time, and that would be a simple interest. We also think of this as sort of informal loans. Talk about borrowing $20 from your friends. Informal loans are often thought of as simple interest because to do compound interest, you have to keep track of how much interest is added every single time. I have some loan, it adds interest because I didn't pay it back. Then I have more interest because I didn't pay it back. And now this interest is more than last time because the percentage was given as a percentage of what you have not yet paid back yet. And so because we don't keep track of that, if anything, I was like, hey, I know that my friend Greg, he owes me $20. That's all I remember, really. Most of the time, I don't care about interest at all. I just want my $20 back, right? But insofar as we discuss informal loans between, non-bank people, we're usually talking about simple interest, if anything, right? Again, a lot of people won't even think interest in this scenario. Maybe more of a, hey, thanks for letting me borrow $20. Let's grab a beer, right? That you can consider that some kind of interest payment. But again, that's not the kind of interest that we'll often analyze in this class. There's no need to make a word problem out of that. If we wanted to force the math into that situation, we certainly could, but it's not something that we often do. Annuities, on the other hand, right? Both of these kinds of interest, by the way, simple and compound, right? Most of them have to do with sort of lump sums. So it's a lump sum saving or investment. And the reason for that is because we're not allowed to put any more money into this account or any more money into this investment after it started growing. Right? If we did that, it would become an annuity. So that's the main difference between these two categories. Right? This is when we're talking about a payment structure. And that payment structure can go both ways, right? It can be payments that I'm receiving, right? Either because I've won the lottery and they're paying me out over 20 years, or it can be a lawsuit that I've won and the company is paying me money over time, right? Or it can be a loan, right? I'm paying the bank back for this house that I bought over time. That's a payment structure, right? So usually the word problems that you'll see involving annuities will go one way or the other, depending on if we're talking about saving versus lending. But in reality, both of them go in both directions. I can stretch present value or future value versions of the annuity formula into any kind of word problem dealing with saving and lending. It's just more often than not, it's just a nice common way to think about it. Commonly, when I'm talking about saving, I'm talking about future value because I want to know how much it's going to be worth in the future later on. And commonly, when I'm talking about lending, I'm talking about present value because the bank pays for whatever you bought today. The bank upfronted you that money. So normally, but not always, savings will usually be a future value concept, and lending will usually be a present value concept, but not always. Be careful. Right? We can see them mixed together, right? I believe we saw a retirement savings problem, which actually had both of them mixed together. It had a savings component, which was future value, and it had a lending component, although it was weird because we were lending the money to ourselves, right? We saved up that nest egg over the course of 30 years when we were working, and then we paid ourselves out over time, right? That is, you could think of that as a loan to yourself. And I'm loaning future professor money, right? That current professor is putting into the bank now. I'm saving up for it by not spending all the dollars that I receive in my paycheck. That is a savings and lending scenario. Right? So there's a couple of good ways to keep track of all of the different modes of money growth that we have. The formulas look pretty similar. Right, here is our simple interest formula. A equals P times 1 plus RT. And that thing looks like a straight line because it is a straight line. Right? If we looked at this thing on the graph, it would start at the present value P. And the slope of this line would be R, right? The interest rate. But this is a straight line. If this brings back feelings of y equals mx plus b, kind of lines from an algebra class a long time ago, and there's probably a good reason for that. It is that kind of growth. The compound interest, on the other hand, brought in this idea of exponents. Right? So now I have p times 1 plus I to the n power. Right? I wasn't using the r and the t version of the formula. I'll write it down just because I wrote it down in a previous note, but I do not use this version of the formula. Right? I will not choose to use this one. I'll always think about the fraction, think about the multiplying, and just use the other version of the formula. If we followed this type of growth, it would start at some p-value and it would bend. The bend might not be so characteristically sharp, right? If you were thinking about a savings account, what you had, right, which has a very low interest rate, that bend might be so slight that by the time it finally gets around to bending like this, it might be 150 years from now, and you'll probably be dead, right? That's the power of compound interest. It will always get to that bend, but if the interest rate is really low, it's going to take a really long time to get there. But it's still, right, it's the same percentage for the same accounts. Right? It's really interesting. Right? So I usually draw my compound interest graphs with a very, very sharp bend very soon, right? Just because I want to emphasize that it's not a linear thing. Right? It's getting that snowball effect. We had several different formulas for the annuity case. And remember, in the annuity case, we had to keep track of this payment idea here. And that payment was how much we were adding to the account every period. Same thing for the present value, excuse me. Same thing for the present value. The present value, oops, not equals, times. That would have been 1 minus 1 plus I to the negative n power. Remember, we talked about why it was negative. You could think about that as ungrowing something. All divided by I. And we could flip both of these or any of these formulas around. I know that these formulas are kind of solved, quote unquote, for A, FV, and PV. But using the tools from the ERL family that we talked about a couple of weeks ago, we could solve for P in the simple interest formula. We could solve for R. We could solve for T. In the compound interest formula, we can solve for A or P or I or N, right? In the second version of the formula, we cannot solve for M, not directly. But if we had to, quote unquote, solve for M, I would just tell you to plug in a whole bunch of numbers until the numbers worked out. It's not a very elegant solution. But sometimes in math, the inelegant solution is better than not having a solution at all. Right? So if you do this on your exams, let me know. Right? I'm not going to punish you for not doing things the most efficient way, but you may not be able to do them the right way just because you don't have enough time. Right? You're under a time limit for the test. We don't have time to plug in a bunch of numbers for every single problem. In the future value, present value formulas, we can solve for future value, present value. We can solve for the PMT. We can solve for the N. We cannot solve for the I, again, unless we just plug in a bunch of numbers until it works, right? Because it's in two different places at the same time, just like the M was in the compound interest scenario. It's in two different places at the same time. We can't really deal with that. By the way, if I drew a graph of this kind of growth, it would start at some p-value and grow for a while, but then it would jump. That would be the PMT, right? And then it would keep going, and it would jump again. You see how the growth is not just the growth from the bend, the growing, the natural growth, but also these sort of vertical jumps. That represents the PMT. How much money we're putting into this account every time we do so. It instantly jumps. up from one level to the next. That's a pretty neat looking graph. Now, again, we don't get into that too much. Right? I promise, right? Because we're not the kind of graphical class like that, right? This is not like a calculus-based financial math class. But it is kind of neat, right? You don't have to understand very much of anything other than it grows with jumps because that represents the PMT. I believe there's a homework question like that to that effect. So the people that have watched this video will recognize these graphs when they see them again in the homework. But generally, like I said up above, right? The first two are all about lump sums. Anytime you see a payment structure, you know it's annuities. Usually we're talking about banks and investments when we're talking about compound interest. But you do have to be careful. It's a decent little primer. The main topic I want to talk about today and share with you in today's video is called an amortization table. An amortization table basically deals with all of the nitty-gritty, nasty details of keeping track of how much interest you owe, how much you're paying in, and exactly to the cent, keep track of your dollar amounts. Remember how when we were dealing with the formulas from up above, like even as simple as this formula for compound interest, we said that every now and again it'll be very slightly wrong because, right, when you have those really high exponents or high values of n, there are going to be a lot of decimals there. When we're talking about dollars and cents, we have to round that off to the 2 decimal places. Right? And so because sometimes it might round up to an extra cent or round down for those fractions of a penny, right, it might over time get a little bit off. And that's what the amortization table is doing. It's going to be doing this mostly in the context of present value, future value. And present value, most especially because we're going to be doing this for a loan a lot, right? You might even search Google for loan amortization tables, right? You'll find websites that can make the full table for you. And the homework questions are going to be, and the exam questions are going to be written in such a way that you're going to have to know something about this table, though. Right? Just having one of these tables available isn't enough to understand what it's telling you, which is what we're doing today. I mean, you might recognize this word or this root word from amortization table, right? It's mortician, like death, like mortician. And it's not just trying to be, over dramatic. Basically, this table kills the loan. That is, you continue this table until your loan is finished being paid off, right? Until the balance is 0. And so what this table is going to do is going to keep track of your payments, how many payments that you make. So sometimes this is called the payment number, sometimes it's called the period number. Anyway, it's keeping track of how many periods or how far into the future you are. Right? It keeps track of your balance, your payment. That payment will usually have to be calculated as a separate future value, present value calculation. But inside that payment, there's going to be some amount of interest and some amount of principal. Because we know that whenever we make a payment on a loan, we're not paying all towards the loan interest, and we're not paying all towards the loan principal either. We know that when we pay, the bank gets a little bit of that money for interest, and the rest of it goes towards the balance of the loan to bring it down. As a matter of fact, when we were talking about credit cards before, I've already got this kind of growth up here, right? If you're not paying on a loan at least as much as the interest is, then it's going to keep growing, right? Because your payment doesn't even cover the interest And so the balance is going to go up over time, and it's only going to get worse. That's why they tell you, all the financial planners will tell you, you have to at least make minimum payments on all of your loans, because it's going to keep it from getting worse. And yes, it might feel disheartening sometimes because you're just making minimum payments. The minimum payments are awful because you'll end up owing a lot more in the end from all the extra interest, but you don't want to make it worse, right? Just because it's not getting better that fast, right? I would much rather it not getting better that fast to it's actively getting worse, which is what happens when you don't make a payment at all. So sometimes amortization tables do not contain a separate column for payment, right? That payment is going to be the same all the way down, right? Except perhaps the very, very last payment. So sometimes this column is omitted because the payment is equal to the interest plus principal anyway, right? Those two things added together should equal the payment all the time. Right? The final balance is on the end. So I count 1, 2, 3, 4, 5, 6 columns in most amortization tables. And some of them will be a little bit shorter. Again, some of them will not include the the payment as a separate column. Right? But every amortization table will at least keep track of this idea. How much am I paying and how much my balance has gone down. Some amortization tables do not contain a balance column at the beginning because every month it's just the number from the end is just going to roll down to the next line. So rather than repeat the numbers all the time, some tables do not repeat the balance column at the beginning of every row. And maybe your homework has questions like that with shorter tables. Either way, this is just a tool to help us keep track of our loan or our investment over time. Okay. So let's make our first amortization table. Let's pay off a, let's say, $6,000 loan in 3 installments. I chose such a small number of installments because I want this table to only contain 3 payments before the loan is paid off. If I was doing this for like a mortgage every month for 30 years, that's a lot of payments, 360 total. I don't want to make a table like that. I'll have to have Excel or another computer program help me do the arithmetic. Computers are really good at doing arithmetic really fast. So let's see, let's let there be, just because I don't want to write a whole paragraph's worth, let there be 10% APR. That would be the interest. So 10% APR we pay per year. Right, and we compound yearly. Remember, in future value, present value, we always have to have the same interest rate time period, the same payment time period, and the same compounding period. All 3 of those had to match. I tried to make this as simple as possible. Make them all yearly, give you a yearly interest rate. So if we're paying off a $6,000 loan in 3 installments, that's a present value thing. The present value today is $6,000. Let's calculate what my payment, PMT, needs to be to pay off that loan in 3 installments. I'm going to grab my formula. Again, I write it down all the time. Everyone always asks me, Professor, how do you memorize all these formulas? I've written them down a million times. Don't think you have to have all of these formulas memorized the same way I do. As a matter of fact, if you wanted to make a little note card to use on your exam, it's not a bad idea, right? I can't sit over your shoulder and see the note card that you do or do not use on your exam. right? I'm really good at telling students that have typed it into like an online calculator and just giving me the result, just because usually students don't actually understand the result. And so I'll ask a lot of questions about understanding your results, because I want to know if you actually know what you're talking about. Anyone can go to Google and say, "Okay, Google, plug these numbers into a formula for me." But the reason we're taking this class and the reason we're doing this is so we can actually get a better understanding of what's going on. Let's plug some numbers in, right? Speaking of Google just plugging in numbers, let me plug some numbers in. So we know that since we're calculating the PMT, that means we need to use the reciprocal version of the fraction. We talked about this last week as well, being able to manipulate these formulas. We can calculate the PMT by flipping that fraction upside down, multiplying it to the other side. Now that it's in this form, I can plug in my present value, 6,000, move that down. My present value, which is 6,000, and then multiply times this fraction. My I was 10%, and since that's an APR, it's not split up by month or by quarter. I don't need to divide that by anything. Normally, we would have a fraction in this position. But because it's APR and because it's compounding yearly, I don't need a fraction. Same I. And it's only -3. It's only 3 payments. Right? Again, I know that most of the time, this will be a number like 36 or 48 or 60. Okay, we're doing this on the cheap. So let me type these numbers into my Desmos calculator really quickly. No. So projector mode, make it a little bit bigger. Let's make this $6,000 times fraction 0.10 over 1 minus 1 plus 0.10 raised to the power of -3. $2,412.69. 241269. Remember, I always round this to 2 decimal places. And before we run off and start making the table, let me get a little bit of understanding what's going on here. I'm paying off a $6,000 loan in 3 installments. Well, if I didn't have any interest whatsoever, how much would I have to pay in 3 installments to pay a $6,000 loan? Think of that as a 6 months no interest kind of cash value thing. If there weren't any interest, the payment would be $2,000, right? Because 6,000 divided by 3 equal payments is 2,000. Right? So my payment should be at least 2,000. If you ever calculate something like that and the payment is not at least that big, you've messed up. Right? So I use that 0% interest just as a reference point to make sure at least I'm not completely crazy. The actual payment we calculated was more than that. Right? And I guess rightly so, because there's $400 extra worth of interest here. 241269. I'm going to come back up here, put that in the payment column. I had to calculate that payment separately. And that's the first thing I do in every amortization table, is to calculate the payment. Well, let's start. On the first balance, I start with $6,000 balance. I make a payment. Now that payment doesn't go directly to the bottom line, right? I actually need to calculate how much interest that I owed. To calculate interest, I use the balance. That's how much I currently owe. And the interest rate, which was given in the problem, 10% APR. So let's calculate what's 10% of 6,000. That is $600. And if you wanted to do this on the Desmos calculator, you could type 10% like that. Now it looks like it wants to see the other way. 10%. Clear. It's 10% of 6,000. I don't usually use that particular feature of the Desmos calculator, just because it really bothers me to have to type that in that very specific way every single time. I just turn it into a decimal and I use the decimals. In any case, I have $600 worth of interest. Lucky for me, I'm paying more than that. So the extra goes to the principal. Let me grab my little calculator for these kinds of calculations that I don't need to show my calculator every single time. I'm going to take my payment, 241269, subtract the interest to figure out how much excess goes towards the balance. 181269. Right? Again, this principal is payment minus interest. And this interest is the balance times the interest rate, I. If you wanted to think about it, a formula, right? This PMT, this came from plugging in the PMT into the FV formula from down below. So during the first payment, I've paid $1,800, 12 cents, and a little bit of change towards my final balance. So let's do that. Let's take the initial balance and subtract the principal payment from it. So my initial balance was $6,000 minus $1,812.69. 418731. So after the first payment period, that's what my final balance is. Remember, it's more than 4,000 because the initial payment, it was more than, this is interesting. The initial payment is more than 2,000. Remember, think back to that 0% interest case. In 0% interest, that would have been exactly a $2,000 payment, and my final balance would have been exactly $4,000. I'm paying more interest than the $2,000 zero interest case, and my final balance isn't even going down as fast as the 0% interest case. Oh my. I promise we're still going to get there in 3 periods, though. In period number 2, let me copy down my balance from the previous row. And this is a little bit like balancing a checkbook. 418731. I'm still making the same payment, 241269, but I need to calculate my interest. So that's 10% times 418731. Times 10%. That's the way I would normally do it. 441873. No, that seems really high. That does seem really high. Go back. Aha! I had an extra 4 in there. So 41873. Get rid of that 4. I saw that number next to the interest, and I knew that the interest amounts, they will go down over time. As the final balance comes down, so too will the interest. So if your balance is going down and your interest is going up, like mine was, I knew that something was wrong. Right? So I can immediately, before I go too far, I can immediately say, hey, I goofed up. You know, let me take a moment to step back. Where did I mess up? me take my payment, 241269, minus my interest payment, 41873. Subtract those two, and I get $1,993.96. Okay. Here's something else to notice, right? Because the interest amount is going down, my principal amount is going up. And again, I should kind of expect that because the payment hasn't changed, but the interest is going down. Right? So over time, I'm actually paying more towards the balance. To calculate that final balance, I'll take my initial balance, 418731, minus my principal, 199396. My calculator says $2,193.35. Okay, 2 payments out of 3, just one more. This is the last payment. And the last payment of every amortization table will be a little bit different, because if I took this balance from year number 2 and I just did my payment, 241269, it seems like too much, right? Well, it might be. Let me calculate first how much interest there's going to be, right? So this last payment is always filled in at the end, right? I need this payment to be exactly as big as it needs to be so that the final balance is 0. Well, I need to figure out exactly how much that is. So let me calculate my interest, 219335. Matter of fact, I'm going to be super lazy. Because I'm multiplying times 10%, do you see how I just moved the decimal place one time? 219335, and then I rounded that to 34. I moved the decimal place exactly one time. Right? Most of the time you'll have to use a calculator, because most of the time you need to multiply it times a weird fraction like 0.08 divided by 12 or something silly like that. So let's see. I know that this balance and this principal, right? This principal should completely pay this off, right? 219335. Notice how the final principal is the same as the final previous balance. Right? These two numbers are always the same. That's how I get $0 in the end. Well, if I calculated my interest and I calculated my principal payment, how much is my total payment? Let me add those together. 21934 plus 219335. It says my final payment, which is calculated, comes from 241,269. And wouldn't you know, that's exactly the same as my payment always has been. Oops, I turned off my computer. There we go. Sorry about that. I'll give it a moment to catch back up. Sometimes it looks a little silly when I first turn on the computer. Okay, so in this case, right, the payment ended up, the last payment, being exactly the same. That won't always be true. Sometimes it'll be off by a cent or two. And in this case, because there were so few payments, it wasn't a big deal. Because all of the times that I had to round in this problem, right, the errors will add up eventually. If you're doing a longer problem, like a loan for a car, or definitely a loan for a mortgage, right, those errors will cause that final payment to be just a little bit different. if you're talking about a house mortgage, it might be $2 or $3 different than all the other payments. But always calculate it the very end. And so this last payment is always calculated differently. And like I said, in this case, we didn't actually need to do that because it was the same as the previous payments, but it won't always be that way. And we don't know when it will be that way and when it won't. So I can't give you anything to look for in the future to say, oh, hey, and the last payment's going to be different. I can't tell you that. You just have to figure it out every single time. This is an amortization table. It's a very short one. It's a very small one because there were only 3 periods. But you can do this in Excel. And I've even linked a YouTube video in this week's homework on how you can do this exact same thing in Excel. Right? You see I've kind of written my formulas up above for payment and interest and principal and balance. If you're okay with Excel, right, you could probably turn those into formulas in Excel right now. You don't need any special training to do that. If you've never used Excel before, like I said, the video that I linked to in this week's homework walks you through it step by step, and it helps you calculate the full table using Excel. And that's good because I believe one of this week's homework is going to be a very long amortization table, and it's going to have sort of a non-standard payment at the end of it. And so look out for that homework problem. It'll be nice. I don't want to take up too much of your time today because this week's topics are really light. Before I let you go, I do want to mention that the Blackboard page, we switch back to the full screen here. The Blackboard page on the signature assignment is now live. So if you go to Blackboard, this is the only assignment this semester that we're going to do outside of my open math. I wish I could do it differently, but trust me, the college makes me report this assignment differently and special. And so what I'm going to do is I'm going to click right here on signature assignment. Right? I'm putting my finger up there so you can see me waggling it around. It's right there, signature assignment in the left side menu. This is the assignment. I can't help you too much with it because technically I'm not supposed to, right? You're supposed to be able to do this all on your own. If you've done well in this class and done all the homework assignments, you should be able to do this assignment. So post in the boards though, right? That just because you can't ask me, quote unquote, doesn't mean you can't ask each other. Right? So feel free to post on the boards about this, or feel free to get together in the group me about this assignment. It's not super hard, right? It's all about financing cars, right? Loans, right? We've already done this kind of time value of money growth, right? It's just asking you to give your reasoning in the form of a paragraph, which I don't think is too crazy, right? It's due on Sunday, so don't panic over it, but do keep it in mind. You'll turn it into Blackboard exactly where you found it. In this assignment here, click General Education. I need to change that to Signature Assignment. So by the time you go to look at it, it might not say General Education Assignment. It might say Signature Assignment. And as always, whenever you submit something in Blackboard, always, I'm going to hide my camera for a moment. Just one moment. Boop, gone. Right? Don't forget to hit that Submit button down here at the bottom. A lot of people will upload a file. They'll scroll down here. Oh, hey, I'm going to upload my file right here. They'll upload the file, but forget to press submit. I can't see it if you don't press submit. And I have to count that as a 0. And I don't want to do that. So please don't make me do that. Bring my camera back. There we go. So that one's, just wanted to put that on your radar for this week. Also, this week, you should be able to see it in the calendar now. Excuse me. There we go. Exam 1 is listed for this Sunday. It will open up on Thursday. You'll have all weekend to work on it. You will have 2 hours to work on it, so it will be a timed exam. Right? And let me just, I'm going to preview it. By the way, there will be a page that asks you for a password. I'll type the password into my Open Math. So if you, like, when you see the password box for the assignment, just look a little bit farther up that exact same page and it'll be typed there, right? So don't feel like you have to go searching for it. You'll submit the honor code, right? I'm going to be manually reviewing everybody's assignments. So you'll just do the honor code, and then the very last question, there's only 11 questions right now, but there will be more come Thursday. Oh no. Do the page. I don't want you to see that one. You didn't see that, right? Don't tell anybody. Basically, there will be questions. This page. No, not that page. Oh, this one. I didn't put it at the very end. I will put it at the very end though. Right? The work submission required. Everyone, you're going to have to turn in the work that you do. Right? The directions for this are on Blackboard. Right? And there will be a folder, if there's not already one there. There will be by the time this video goes up. A folder called Exam Work Submission, and it will have the directions for you to submit your work, because I'm going to go and look at it as I grade and give partial credit to all of your test questions. Right? And as you see in this acknowledgement here, if you don't turn in your work, your score is a 0. Your work doesn't have to be super complicated. Remember, we're allowed to use calculators, so you can say, hey, professor, here's what I typed into my calculator, and here's the decimal it gave me. I'm okay with that. Right? But I need to see some form of work for every single problem. And it'll probably take me about a week to get all of your exams graded. Like I said, don't panic about this. If you don't know how to do a PDF on your phone, right, that's fine. You can submit a bunch of pictures. I can do that manually. I just like PDFs just because it makes my job a little bit easier. Right? It's much easier for me to deal with PDFs because I can draw on them using my tablet the same way that you see me draw on all of the OneNotes here. But that will go into Blackboard when you take the exam. Remember, I'm always available via email and the live sessions. Right? So I hope to see you later this week. And good luck on your test, everybody. I'll see you next week.